where you are joining us from. And as you can see, we are ready. And today's session, our special presenter is Santosh Dogam. And his topic for us today is data mesh as the foundation for AI ML in financial services. And as you can see, I'm at the intro. I have to get out of his way in about 2 minutes, and so that we get to learn all that he has prepared for us. You can be part of the larger community beyond just these live sessions we have. I'm going to share where you can find all about the community, the pages, and we want to make the conversations keep happening even outside of the, mostly one directional webinars because we learn here, but we want people to also engage beyond this learning that happens twice a month. So our special guest, Santosh, is a data engineering and analytics leader with over 20 years, building high-scale data platforms across retirement 401k, broader financial services, and healthcare. He's someone who likes to share his knowledge. I think he writes even in, in papers and then publishes in journals. That's the extent to which he tries to share his knowledge in a very well structured and heavily vetted way. And so we are fortunate to have him present to us on something that is very practical, something that we can learn from his experience, and we can see how most of these things that we are aware of as concepts, data mesh, AI, ML, and the industry, specifically financial services, that he's got decades of experience in. So I'm going to get out of his way so that he presents to us what he has prepared. So over to you, Santosh. Thank you very, very much. I'm going to stop sharing my screen and then I'll go into the chat. If you have any questions, feel free to put them in the chat. I know at appropriate times, Santosh is going to address all your questions. So over to you, sir.
Sure, Michael, just give me a second. Let me share my screen. I hope you guys can see the screen.
Yes.
Okay, cool.
Okay.
So I think thanks, Michael, for that introduction. Yeah, I am Santosh Durgam. I'm leading a data engineering team in Morningstar Retirements. I look at every participant's information, and we are trying to make investor life easy. So we were looking at every angle of the data point and make easy of investment decision what we do it for them. So that was like our motto, to make it easier for them to consume the data and make it a financial decision, which is like a very tough decision sometimes. So we want to make that as easy as possible. And it's not only for the investors, it's also for the people who manage those investments, people who manage those expectations from the regular investments. So we look at all those angles and make the data engineering as much as possible to the end customer, where the life becomes very easy for everybody. So that's where I am from. And good evening, everyone. So I'm based out of Chicago. If you guys are anyone from Chicago, that would be fun to like meet up. So that's like me. And so today we'll be speaking about data mesh as a foundation for AI and ML in financial services. I think this is like one where everyone is running towards right now. I think because of LLM becoming very dominant in the industry right now, everybody wants to use some part of AI on their regular web applications, data engineering, and the data use cases. So this is where our take on a data foundation, where we need it like mandatory to get it to that level. So let me put this in a very good context to when we start this. I think when we started this journey a few years back, when I joined Morningstar like 5 years back, we didn't had a data governance, or we didn't had anything around something like that, where we are ready for anything which is coming up for LLMs, whatever we see today in like last 2 years, whatever the development it has happened, we are not ready for any of that stuff. So we took like 5 years back, we took a step where we want to like build our data lake foundations, whatever we need, and we want to build governance part of it, and we want to start using that data for multiple use cases. It's not only for data engineering uses where people will go and build a report and forget about it. So we want to take it to the next level where we want to build a use case where everybody wants to use the data in their own way. So where that's where like we started our use case journey. So we started like how the use every role in Morningstar retirement uses our data, and we how do we want to trace it back to the actual foundation so that we can build our foundation from there. So I think when I speak about data mesh, I think everybody knows about data warehouses, so data lakes, lake houses, and then it's like another level of abstraction is data mesh. So we'll be speaking about all these jargons a little bit detail. So I want to put some analogy where everybody can start making up their mind when we look at data lake or data mesh or something like this. So let's start with data lake. It's like a building a tower in one city, and data mesh is making actually a city where you have multiple towers and you need to manage, and you have different ownership and different governance models around it. So how do you run with that? And how do you make sure that everybody follows some principles to build these towers so that everybody can access or everybody can go through those. So think about this: if you have a one tower which everybody has to pass through that, and if you have only one ownership which has to go through that uh, one system, it becomes like a bottleneck for everything whatever we do in future. So to avoid that, we want to like distribute the ownership and distribute the governance model. That's where our data mesh is little different from anything whatever you guys see on a data lake or a data lake house architectures. So I am speaking about a data architecture is like a city. So that will be like mostly my take on this. So if you guys have any questions or anything on the way, just keep it on chat. So Michael can pick it up whenever he has some time, or like whenever we stop and take a pit stop to answer those questions. Okay, let's take it to the next step. Okay. So when I was speaking about lake houses, data lakes, so everybody has their own way of creating data lakes or lake houses. So we also started something like this. So everybody knows the pain of having a data silos. So I am from a retirement. Morningstar deals with a lot of other data sets. So we have trading data, we have wealth information, we have advisor data, we have record keepers data. So we have a plan data where we have multiple funds and ETFs going into different types of plans and building up plans. So there is a lot of data which we want to consume when we make a decision. So if you want to like cross pollinate this data and use it, so that's where our problems start like showing up. Like, okay, you can't have data silos if you want to grow further and start using the data. And when we speak about data democratization, right, this will be one of the biggest hiccups you will see when we say, oh, we have a data lake, we want to like make it data democratized. It is possible, but if you have like only one organization, one set of data, then it works great. But if you have a multiple silo organizations where we have multiple data lakes, how do you deal with something like that? That's where our like one of our biggest problems when we look at it. And the other, the common problem I have seen is like AI and ML demand. AI and ML use cases right now. You want to use something from uh, advisor data and you want to show it on our retirement data. If I want to show something like this, that's not easily available. If you want to do a prediction about like, oh, this advisor makes his decisions 95% right, and his uh, growth of return for the participants are like 55% or like 25% or something like this. If I want to propose something like this, you want to like start looking at their data and churning out their machine learning use cases and coming up with some score on advisor. If I want to do that, you need to have access to those data sets. Or if you have some way to like utilize, because everybody does this AI ML use cases on their data sets, But if it is like stays in their own area, if you want not cross using them, there is no use of like building something like this at one point, because you are duplicating your effort in every area. So these are like main challenges we have seen in financial services, because everybody wants to keep their data in silos because they want to control it. They have different names for it. Sometimes it's SOC 2 compliance. It has sometimes it's audit problems. So if you want to build something like this, how do you do this? So that way, that's where we started looking at few solutions where we want to like make it build some we build data lake. Of how and so on. Yeah, and
Sorry about that. I've muted the person.
that's fine. Sorry. So I think where we looked at few architectures and we looked at few problems based on our experiences, and we came up with this means one of the solutions was the data mesh, where we want to like build some principles around the data lakes, how you want to build it and how you want to use it, and what are the metrics for success for a business, and who owns it and how do you manage it. So those are like some principles we want to like run around with it, because you can't run the whole organization's data lakes and manage it, because everybody wants to manage their own way of it. But if we want to build the principles around how do you build a data lake, or how you build a governance around it. So we are like focused on building the principles, not building the data lakes when we first started. So we started worrying about those pieces and start coming up with the principles, how the data lake should be built, what are the technologies involved, and who will be managing what, and who will be managing the governance, and who will be managing the intake of data sets, and who will be managing the feature store of the data sets. So these are like some questions we want to answer it, because we have seen these as a problems when we started this journey, and we want to like start tying up these problems with business impact, because our main drivers for whole this situation was like business. So we want to show it as an impact to the business, so they can be part of this whole data mesh challenges, so they can be part of these discussions on governance or management, so that we can take saying that, oh, if you manage this, you will be like getting your data sets very quickly so that you can solve your problems very fast. So this has roped up all our business stakeholders, product management, and our the data engineering team and the actual engineering teams in our area. So this will be like our we are looking for fixes, right? We want to like instead of fixing it, we were like trying to pave out a path where everybody follows it to solve the problems holistically. So this is where our take on data mesh when we started this. So I think you might have seen some regular problems like we have a data lake. What do we need a data mesh? So that's where like we'll start seeing the problems and solutions going forward in next slides. I think we'll speak about them a little more detail. Okay. Okay. So when I spoke about an earlier step where we were saying data ownership naturally aligns with business domains, right? So how do we want to do that? So we want to like queue out like, okay, if I have a advisor data, or if I have a customer data, and if I have a prospect marketing data, if I want to manage that, so they know their data better than me or my infrastructure team. So I want to divide my uh, the what is this? The way we look at our solutions, we want to own the infrastructure. We don't want to own the logic, or we don't want to own the data sets altogether. So we want like business to own the data sets and data domain ownership, so that they can treat data as their product, so they can start investing in that. So that was like one take on this. So just give me a second. Just give me a second, guys. Cool. So that's like, sorry guys. Okay. So that's one of the product where we were like started focusing on like who owns what. So domain only oriented ownership. where everybody owns their own data sets and the area of data sets, and they need to manage it, and they want to treat it like data as their product instead of saying that okay, data is like their sub output of whatever they are doing. It's not like that. It's like a product, mainstream product, where everybody invests time and energy in it to make their data definitions documented and their data sets documented, so that everything whatever they speak about the calculations behind those data sets, right, that has been documented, so that when we start to use, or like when we want to, like, the consumer comes and looks at their data sets, everybody needs to know what does it mean. So one simple example was, like, I was looking at one example where my product team wanted a salary data of a participant in 401ks. So if you look at that, it says salary. So when I started giving out salary numbers, it's just a number. When it says salary and it's just a number, you can predict it in a lot of ways. So I want to say salary in USD of a participant in a frequency of its annual salary or something like that, because it also has some of the participants might put some data in a monthly salaries or bi-weekly salaries. So I want to be very clear when we calculate any values and put it as a data product. I want to be very clear on the outcome of that and why do we use it and how do you use it. So those are like some things as like as a data as a product, they need to worry about it. And when we have all of this, the third piece is self-service data infrastructure, where we don't want to like start worrying about like serving the ad hoc data requests or ad hoc data reports. So we'll be like, we want to be users will be like worrying about all that. Like they will be like looking at our data sets and building out their own data sets or like reports they want and asking the questions the way it's expected. So those are like some things we want to build it for self-serve data structure and federated governance. I think that's, I speak about security, privacy, and compliance, which I want to involve on every platform level. So instead of like worrying about building a data lake or anything, we started worrying on these four items where we build the principles of this, and we'll start worrying about like how do you solve these principles as a framework. So this is like something we started worrying about every area. If you want to onboard a data set or onboard a table, how do you look at it as like something I want to solve it as a data as a product. So I was looking at these four lenses. We look at every data set we want to bring in and start looking at it. So I spoke about a lot of these items on a very high level, right? I want to like start mapping these principles to some of these to use cases where you can relate it in AI and finance. So domain ownership. So when you look at fraud detection, right? This is like very much about a pattern and behavioral data sets, right? So if I want to look at event of the incident, means event of the transaction and the time of the transaction, and there is a lot of activities happened on a user profile. So if I want to look at that data set, I can actually document those transactions and everything. But if fraud detection owns that data set, when they look at their model, and if they say, I want to use these 3, 4 fields of a participant, and I want to like say if this transaction is fraud or not. So if they want to calculate that, they have their own way of calculating it. And if they want to like how come up with this behavioral patterns or detection models, right? How do you define those, the input data sets, how they want to use it? So if they want like that, if their domain ownership of that fraud detection models or anything, right, that lives with them. Okay. Risk modeling. So who wants to access what type of data sets and who owns it and who is the manage means who will be managing it or moderating those data sets if there is a issue or anything comes up, who will be the product managers. So those are like some things we want to like speak about federated governments. So let's say marketing data set, that's like my personal preference for a lot of these. It's very easy to like look at it. So if I have a credit card data set, and if I want to say, oh, these are like people who uses credit card a lot, and I want to market this one of my product to these people who can like go and buy something on from credit card. So I want to give an offer or like some special offers based on their appetite for risk or like buying appetite, right? So if I want to do that, so they need to know the entire history of their purchases happened and what are the time of the year they do that. So they start looking at all these data sets, and I don't want to give that data set to somebody who doesn't even worry about like day-to-day transactions, right? So if I want to look at somebody who wants loans or anything, right? They might be interested, but not every transaction level. They will say, what is my month end balance of a credit card, right? Of a participant, or all the credit cards, and what is the credit risk on that. So he wants to like very high level data, not every transaction level. So you'll start defining who wants what, and how do you start defining that, and what is these values when you look at where is it started and where is it ended, how do you calculate all those values. So everybody who wants to use those data sets should know what is it contains. Okay, so personalization is like one of our favorite use cases when I spoke about earlier risk modeling, right? So it's the same thing where you who wants to be part of this marketing campaign, and what are the values we have, and how what is our personalization marketing campaign for them. Like you might have seen like going to a app to buy something and you don't buy it, you just leave it in the cart or you just browse it, and you get an email by end of the night saying that, oh, you left you something on your cart or something you might be interested, or better recommendations around whatever you have browsed, right? Those are some things very much personalized marketing campaigns. So something around that might be a lot of financial factors involved for data like that. So this will be treated as a product. So some of these use cases might be very interesting for a lot of people. So some of that, and the compliance, which is not a favorite topic for a lot of people in industry, but you have to stick to that and you have to be part of that conversation. It's I think once you like have your principles clear and defined, I think you should not be worrying much about complaints going forward. So my team has defined the framework and everything, part of those initial principles, where we will not be worried about accessing the data set or giving access to the data set, because that's managed by the data owner who and the product manager who will be part of that. So they know who needs to access. Like if I have a new customer data, if I want to give it to marketing, they know whom should be part of that. It's not sales who should be worried about it, it's marketing who should be worried about it. So that decisions who wants to take access or who wants to get the access, right, that will be distributed right now. So that's like something which we automatically defined by principles. It makes it very easy to think about like what are the pieces of information we'll be controlling, what are the pieces of information the product manager will be controlling, or the actual business owners will be controlling. So those are like some things which helped us think about going forward with any of this mesh. Okay. So I'll be speaking about feature stores. I think I spoke about data mesh is like as a piece of information where you control and do all of this, right? So what is the next step of once you have data in your lakehouse? It's like having your lakehouse in different regions and managing it with a certain principles is data mesh. It's not anything different. So you have your data mesh defined with all the principles, all the governance rules and everything, and then you start building your own data lake. So once you have a data lake, let's say that, so how do you start using it for features? So you can fill, means people nowadays, I think it's like one of the feature requirement which uh, any data set comes with. So they want to like start marking those even data sets with feature stores, saying that this will be a feature part of a feature store. So if I'm speaking about personalization, if I'm speaking about sales, right? So when I speak to sales, their focus will be always on advisors, record keepers, who will be looking at AUM and who will be looking at different plans, how number of plans they manage. So if I look at those data sets, it's like, oh, so we want to see like who are the different types of record keepers we have and what types of features they like it. And it's a list of features, different types of plans they have how many plans they have, how are they growing, and you start predicting like by end of next 2 years, how does it look like? If I want to make it that decision, how do you pitch your services to them? And what types of new features will help them to grow to that level? So if I want to do that, you need to know like what are the features we have available, and you will be start building those feature set or like feature stores, so that we'll be saying that okay, this is something you can start using your machine learning or anything on it. So you have all these features readily done. So I don't know means how many of you guys are aware of machine learning use cases. You might be using something like you will be encoding these data sets, you will be cleaning up for non-zero values, zero values or null values. How do you worry about them? And what are the important metrics you want to use it? Because there is a lot of values where you say, so in wealth management, we always have something called 3 by 3s or like something like this, where you say risk appetite for a participant was very high, and very the same risk appetite for another participant is very conservative or aggressive. So if you want to start speaking about those are like labels. You want to put them into some numbers, so that when you use a machine learning model, they need to know like how do you use that data set, right? So if you want to start thinking about in that angle, so there will be a lot of labels where you convert into some numerical values and encode them, so that you are not actually saying that 0 and 6 are like, if you have like 5 features and if you say 1 to 5, so 5 doesn't mean big or 1 doesn't mean like very low. So you need to be like very evident on those values. So how do you define them, and how do you calculate those values? So these are like some things you keep in mind and like build your feature store. So if you know all these values, inputs and outputs, you can build a better feature store yourself, instead of everybody asking these questions and coming up with these calculations themselves. So our feature stores are big thing. So we build feature ingestion, feature transformation, feature storage, and feature serving. So feature storage is not like anything crazy. I think if we store it in S3 and everything, so we have like features served by means any of our SageMaker Studio, and we have all those available. So we have our data sets, feature stores exposed in that, so that it can take it up and run any machine learning use case in matter of hours, instead of like days or like something to worry about it. So all our data sets and everything are ready when we start like thinking about a new machine learning model. Okay, I'll take a pit stop. It's like 30 minutes on spot. Michael, any questions or anything I can answer it?
I'm looking, no questions yet.
Okay, cool. So I'll continue then. So, okay. So federated governance and compliance. So I think this is where like people speak about governance and compliance, but both of them goes hand in hand. Who owns it and what does it mean? So when we looked at the initial principles of it, right? So this is the only distinguishing factor when you look at the data lake and lake houses will have most of this the remaining pieces, but this is something which makes a very big difference on data mesh, because when you define this, how do you onboard a data set, and how do you worry about the quality of a data set, and who owns it and who manages it? Those are like some things you need to worry about it, and the data masking and everything comes in hand for compliance pieces. So if you define these on every data set, you onboard it. So that makes it very easy for going forward, because you don't need to worry about every time. It's not like a, after the thought of like building a data lake and worrying about it at later. If you start this as like your first step of onboarding a data set, it becomes very it's organic and very healthy to look at those data sets. When you have like 20, it's very easy go back and start building this, but when you have like hundreds of data sets, it's not possible. So that's where we said like learned our lesson, saying that okay, we'll build and start everything from scratch of these questions, or else we'll not onboard it. So it became our norm to like onboard any data set into a data mesh, so that you have this data mesh available for all the consumers, Even though you are a producer, if you worry about this now, you will not be answering all these questions which comes from every team in future. So you answer all these questions at once. So that's where our take for any of these governance and compliance. So auditability and lineage is like very much required for any of our data sets. And SOC 2 compliance needs all our access controls, and data masking is very much mandatory. I know how much, if you guys are in finance background, I think you know like how much PA we'll have and how much we worry about data masking and access controls. We mask every, means we mostly ask these questions, do we really make a difference if we have a PA information in system, or we don't even worry about that. So we will be like have a secure data set vault where we will worry about only PA data there, and a mapping field which can go into every data set in future which we bring in on that participant. So we will be like restricting that part, and everything else falls into the regular data sets. So we will be worrying about only the PA information in secure data sets, not everything else. So that data masking and access controls becomes really easy for us. And this, if you know all these pieces, right, I think this makes it our data lake problem decentralized, because you will be worrying at every data domain level instead of like worrying about at central level. So the data masking, auditability, lineage, policy enforcement across domains, everything becomes like very distributed. So that's where our advantage of building framework comes first, and everything else was like followed later. So that was like one of our advantage when we looked at any of these pieces. Okay, I spoke about this. I'll not. I'll just give a minute to read about it. And if you have any questions, please drop in any questions on anything of these use cases. So this is all about speaking about different use cases we have in financial services. So one thing I haven't spoken yet is like real-time decommission decisioning, where if you have a lot of data, if you have a loan approvals or trading decisions or payment authorization, so those things need a lot of data to churn out and give out a lot of insights. When you have, you will not be means giving out a decision straight away, but you will be helping all the factors who can make a decision when they look at this. So if you want to do something like this, you need to be very aware of all the data points to be showed up when you want to make a decision. So think about your trading decisions. You need to be different angles to every trading you solve it. So you need to be like very much clear on what types of charts or what types of numbers will make them to think about like decision. You want to show alphas, or like you want to show betas of the market conditions of a stock when they look at this, and you want to compare with the current market conditions, or like market conditions of a technology sector or any sectors. So you need to be like showing off lot of these parameters when they click a button to make say buy or sell. Means think about options where they bet a hundreds of thousands of dollars when they do a trade like that. So they need to have all these values ready to make a decision. So those are like some things which was like very much churned out, and like looked at history and everything ready. So you can like start thinking about those items in a real time. Okay, so this is our blueprint for implementation, where we looked at a lot of ways to solve this. So we started with very small domain data products, where we looked at, when we started, we looked at very one or two use cases, but if you have like two or three, it will be like a very good starting point, where we look at domains and their data sets, and go back and ask the product managers and the product owners the right questions. What are the different types of questions we will be solving with these data sets, and what is the granularity you need it, and build those data use cases, and start gathering that data, and start creating that data domain products, so that it can be used for self-service infrastructure, or it can be used for any future requirements and reports or AI and ML use cases. Once we have all this built, and we started iterating it for every, means different domains, so it becomes very natural when we start like we experimented everything with one use case, on one domain, it becomes a blueprint where you can, if you want to onboard one more data set to the same domain, or if you want to build a new domain, it becomes very easy where, because your framework defines everything, whatever you need. So that becomes our naturally very easy to way forward and measure and iterate for any future implementations. So when we looked at everything, so we were like thinking like, how do we start saying that these are like some things we want to like help us and say these are like our success factors. We want to like define it to the business so that every team gets productivity. And we want to like show a use case where these are metrics we will be like showing it to the actual business impact teams, and what are our leading indicators and what are our business outcomes. So when we look at this, so our four takeaways we want to like showcase it to the business was how much was feature use reuse rate, and lineage completeness, and model trust scores, and time to insight. So when you look at time to insight, 40%. So our reduction of effort to implement to bring something a data set and make it ready for insights, right? It reduced to 40 to 60% in 1 year. If you do that, so you can sell this solution to the product managers to adopt it. So when you say the same thing for model trust scores, you can sell the same solution to our data science team. And lineage and completeness, I think this is like one factor where it draw our time to insight, and feature reuse rate, which sold us for our data science and the business outcomes team. So these are like some metrics we worried when we started like thinking about like how do you say your data mesh is success or not. So these are like some of our metrics where we tried and like say that okay, these are like you will be looking at this and what will be the business outcomes. So we will be speaking about fraud detection accuracy improvement, right? You have a fraud detection today and you have some accuracy. If you want to improve it for like next 1% of it, or like not even 0.5% of it, it's a big improvement. So if you want to do that, like how do you say this metrics, whatever we are like bringing in, the data we are bringing in helped us to derive that 1.5% of it. Our model deployment velocity. I think you know this. I think we have a lot of models in lower environment. It never makes it to the production level build data because we never have data ready. Because everybody will be worried about preparing that data set than actually testing their models. So that's where we focused on building up a model deployment velocity is like a big thing, instead of like saying that, oh, we were like saying that our predictions are like accurate. So our deployments are like faster, and say run it in production for like 3 months and say what is our velocity and how accuracy it has built up. Once you have all of this, and then it's ready for production migration. So you switch a flag saying that, okay, this will be your future, uh, what is this model for any of your predictions, future, and just go back and like say you like means a greenfield deployments start using that in future. Okay. Regulatory audit efficiencies. When we built this, we were like thinking this will be our like job managing the infrastructure and managing the access part of it. But after a year, what we learned was whatever we were like trying to do it with KPIs and everything becomes very much automated, and where we were like doing everything with the access controls and everything, which is very much KPI driven, which becomes automatic, which we were not involved at all. So it becomes very easy. It actually reduced our effort on that was almost like more than 60 to 70% on that front. So we don't worry about any audit or anything coming up in next 1 year. So our involvement for audit was like very minimal. So all our audit requirement were like is solved with our principles itself. So we have our reports which can we send it out to the audit team, and then we are out of that business of like serving the audit requirements. So I spoke about feature reuse rate or model trust score that will be defined by data scientist productivity gains. I think that's our business outcome. I'll be speaking a little bit about leading indicators, which was defined by our product teams. So number of active data products, which helped them making a decision or making their product go forward, and experimental bit about AB use cases which they were thinking, and cross-domain feature consumption. Whenever I speak about advisor data, and whenever I speak about participant data, and in the marketing front, so they're like two different use cases. The same marketing does the marketing for both of them. If they want to start using that, like they need to know about like what are the values they are bringing in, and what is the feature they are like trying to use it for marketing. So those are like some things which we looked at it, and those are become our leading indicators for all of this. And one feature which we always focused as a data engineering team was self-service success rate. So we want to avoid building a cookie cutter reports for every team we onboarded. So our success rate of self-service defines our infrastructure we want to build and manage. So we focused on that more than building our cookie cutter reports. So that helped us cut down the effort on that and building focusing on self-service, so that the same infrastructure model we want to apply it in everywhere. Okay. So we looked at all this, and we want to like start, we learned our lessons about how this solved our problems, and what are the things we want to like uh, we want to avoid when we build our data lakes or any new domains. So we want to avoid centralization creep, where everybody wants to like control everything from centrally. So we want to avoid that. We learned our lessons, like if you have a clear boundaries, what's been done, who is responsible for what type of activity, and what type of data quality, and what type of business logic, and who will be serving and who will be managing it. And if there is a problem with data set, who will be managing that expectation of clearing that data quality issues, right? So those are like some things we want to avoid uh, piling up on a centralization. So we want to distribute that. So that's like something we learned it with involvement. Means when we looked at initially, I think these are like some things we learned and said, okay, this is something every team will take care of it, instead of like we worry about this part of every domain or data set. So data means lack of governance. So we started like seeing, initially we said, okay, we want to make onboarding as easy as possible. So everybody start bringing their data set. And if I want to like document those data sets, it takes ages because it's not the priority to document the data set. So we went back and said, okay, we will be updating our policies, that everybody builds their governance first, saying that who will be accessing it and what will be like part of data set, and documenting the data set, and by when. And if they want to onboard it, we started building, there is a one more layer to it, saying that you can bring in any data set which will not stay more than like 3 months in the area which can serve it. If you want to actually means promote it to the actual area where it can be used by every consumer in the organization, then you need to have data governance done, or else we will not be able to push it to the data governance. So those are like some things we learned from our experiences. So okay, so that's like part of governance. And poor data product ownership, which is like one where aspect of who owns the data set, what is a clear SLA for that, and who owns the data set from the business standpoint, and what are the product stewardship roles, and what is a data stewardship role as a product manager or a product owner can do it, and how does they are responsible for successful metrics, right? So those are things which we haven't defined earlier, because we thought like every product owner or product manager understands their data sets, but we started learning it in a hard way. So we started like explaining that as like our main principle. So when we start building our data set, every product manager should be aware of this, and every manager should be like thinking this as like their metric when they onboard a data set. So ignoring complaints early, that's like a fourth piece I spoke enough. I think building all those complaints pieces, part of the principles, helped us building everything whatever we wanted, because we don't want to be like worrying about it later. So So I say, means I think this is like one, we started experimenting with one domain ownership and started building these problems and started solving them by piece. So what we learned was we are still learning in some places where how do you publish your governance pieces, right? How do you publish your metadata? How do you publish your self-service as a model? So those are some things we are like experimenting a lot and learning it and implementing some solutions which can make the life easy for some of the engineers and some of the product managers and some of the business stakeholders. So we need to like start figuring about the ways. But when I why I'm saying is data mesh is all about like how do you actually experiment and give out some solutions. It's not like a destination. These are like you always keep learning small and you start growing from there and like scaling it. So focusing on journey, it's not a destination. So that's like one thing I learned after all these years with Morningstar and with the data engineering teams. Okay, so that's all, and that's my LinkedIn. And if you guys wants to connect, and that's my LinkedIn connect QR code. If you guys are like, feel free to connect on
Right.
LinkedIn. And if you have any questions or anything, if you haven't asked here, and if you are looking at your recording, feel free to connect on LinkedIn and ask a question if you have anything on data engineering, data governance, machine learning, or AI models. So this is like one of our journey where we started enabling our data for AI, LLM, ML use cases very fast. When we looked at 2 3 years back, we had a lot of metadata where we were like experimenting, and we had our self-service model, which built from very basic lang graph and lang chain, and we experimented few pieces like almost like when OpenAI came with API. So this helped us to think about like what are requirements we need when we say our data mesh is ready for next generation things, right? So these are like some things we were experimenting parallelly to say how do we define our metadata, or how do we define our data governance, or how do we define our data sets. These are our lessons learned on the way. Feel free to ask any question on this front. So I'm on LinkedIn, or if anybody has any questions right now as well.
Yes, we actually do have questions. So it's like you perfectly, stopped at the moment that gave us enough time to address questions. So I'm going to read them in the order that I have. Some are in-house questions, but luckily they are in the chat, so I can follow the sequence that we've put them in the chat. Uh, so question one is, these frameworks, do they require that the entire organization have to use same data platforms? Like for your organization where it's really large, does that mean that you have to force all the teams to use the same platforms?
I think, yeah, that's like one of our principles, like what is our tech stack we will be using and how we will be using, what types of tools we will be using, because everybody will not, means I think we are on AWS platform when we started. So everybody has their own way of solving data ingestion, and how everybody will have their own way of data storage, and data serving it will be their own way, and data governance is like a completely off topic. So it's like they have their own ways to solve these problems. So what we did was part of our principles, our tech stack is defined, and we also wanted them to like stick to those principles, because when we start consuming the data set, means it's like everybody has their own way of solving it. But if you have a uh, we had like few folks where they had like, okay, we have a lot of API, we don't want to like start investing on writing a Python job for it or something like this. So they started bringing in some tools like, what is this, Singer iOS. It's like a ETL tool where you can have a tap on source where you, but what we defined was like how your data should be landing, the what format you should be landing in, but you should be using our data source, right? How do you define your data sets? And what when you say, even though you brought it with Python or a scoop job to data ingest, or a singer, it doesn't matter. Your end data set will be in Parquet data set. Okay, you will be putting in S3, your raw layer. I think you guys all know about medallion architectures or anything, right? We've almost enforced like medallion architecture. So you will drop everything into raw and you consume and clear everything from your next layer, which is silver layer. And when you have everything like clear and you go to a gold data set, that's where you come and publish your data set into our data lake for everybody to consume, because we don't want like half-cooked data set. So we have our principle says you can use AWS infrastructure, whatever you need upfront, but you will be publishing in certain standards when you publish it to your the final layer. So we have some time. We started with Redshift. Now we are moving out of Redshift and moving into Snowflake, where it becomes like your LLM use cases and your AI ML use cases becomes a lot easier when you have a market store for Snowflake, because you can like cross use the data sets very easily.
Oh, thanks. So the second question is, in this webinar, you have used AI ML as a use case, and I think the question ties with even what Zia is asking, but let me just not jump. So the question is, you have used AI ML as a use case for this session. Does that mean that data mesh is usually set that granularly, because on the slides at some point you have to mention, how you also track usability and success and some other metrics. And the question is now, does that mean one have to go that granular in the process of setting the data mesh? And does that mean that companies will have different data mesh setup for different business domains, these different organization use cases?
So I think don't think like it's a business case focused. So think like it's a organization focused. You will have one organization will have one data mesh, and
Oh,
you will have every department will have their own. So let's say this example of your HR department and your finance department and your marketing department. They're like three different departments, and you have one data mesh which will host the data sets of different domains. And HR domain will have a data set of a participant, their salaries and their performances, and a lot of other data on user behavior, right? So how many times they come to the office or like anything around that, attendances and anything. And if you look at finances, it's all about like how much you spend, how much your salaries were like in terms of assets, or like how much you are like spending it in energy of your day-to-day operational salaries or anything, right? You'll be speaking about a lot different levels of granularity and lot different types of data sets in every domain. So always think like it's a data mesh is like an organization. It's like an enterprise level initiative where you have your own data lakes, which will be focused on solving your problems first and making your data set available for to solve everybody else's. So if I want to see the performance of a parties, so if I'm looking at engineering productivity as a part of engineering team, I'll be speaking to my HR team saying that give me the performance data set of this uh, experience and this role, and how much they have performed and how is their ratings look like and how is their salaries look like, to say that my team is doing better, so I need to be like bumping up their salaries, or like I want to like jump down and say you need to move little further to say you have like ready for your next level of role, right? It comes with all the data, but you have that data ready so that I can, being an engineering team, I can make a decision out of HR data system.
no.
So right now, think this is available from Workday right now. You don't see like this is like something out of your uh, means data lake, but it's actually surfaced from one of the data lakes in upfront.
Yeah. Oh, thanks. That's correct. Fully addresses that question. So the third question is, how is compliance and best practices enforced? Is it mostly tilted towards IT approvals for resource provisioning, or you use specialized tools to create guardrails for the users?
I think guardrails is very new thing. I think yeah, that's right. I think yeah. So we had our principal says like product managers, we have some structure called like who gets access and what types of access. You define it when you bring in the data set. So we define it like he's a consumer, the one who will be a producer, and who will be like reading it, but some restriction to the data masking, because you don't want to read a participant user and participant salary being a engineering team. But if you are
Right.
looking at a finance guy, he needs only the salary, he doesn't need to know the name, right? And origin of the user or anything. So those are like some things we defined at a very uh, principal level, so that lake formation, when they define the framework, they'll be looking at every data set on their platform, says he'll be the consumer, he'll be the, these are like some restrictions on every data set, so he'll not be getting it. So every domain will have their own roles and how do they access it, and that will be defined by very much like a producer and consumer roles, which will be applied entire organization will, when you say you are producing it, you have the control what data you want to expose and what data you don't want to expose.
Oh, I see. So it's more of like it is structured in such a way that from that beginning, even before the data begins to come in, you've already put that structure in place that's been created. It's forcing people to follow those
Yeah,
framework.
that's right. I think that's where I said like you, when you bring in your data set, you define every column, every data column of that data set, and you also have the entire data set will be like access part will be predefined, so that you know like what types of users and what type of data set we are trying to use it. And you will also say that what are the things you need to mask when people uses it from which type of organizations.
Clear. So Rajesh has a question that I'll read it exactly as I'll read it as he's written it. He says, I see feature reuse. So there's a slide you had that shows the outcome of, I think, when people started to follow the framework. And so in there, he said he saw feature reuse rate of 65%. What is the mechanism to avoid computation redundancy? That's his question.
Okay, so think about this data example I mentioned about HR teams, right? When we have a HR team produces a data set where it says this is a performance data set of a all the employees and all their salaries and everything. So if we have one thing like that, and if we have, what is this? If you have calculated all those performance factors and says this is a competency level and this is a score for it. So once you have defined it and you know how to calculate, because being in engineering team, you might not know how do they calculate it, their calculation of coming up that competency score and readiness for next level or anything. So you don't know those formulas. I think if you have those formulas calculated by HR time, you just consume it as a consumer. That's where you avoid the duplication and means recalculating it from other angles, because you don't know the actual business behind it. So you might like avoid that calculation. So that feature reuse, right, that actually increases when you have all those values defined and calculated. So people start using those features than actually going and recreating them from scratch again.
Mm, see. Rajesh, is that answering your question as satisfactorily? So I move to next question. So how would I think you've kind of answered this, but I'll still read it. So how would implementing this data mesh, be for general reporting? As you've used the example of AI and ML, and this you mentioned very specific concerns that and the pattern that seems to be very established already. But for teams that are like sales and finance, where they like to do a lot of ad hoc reports, strategic reports, where they cannot even give you a structure ahead because they too are adapting to a marketplace that is not rigid and they don't know exactly what they would need in some point to come up with some campaigns or some change or some. So, in short, for teams that they want that flexibility where they cannot give you all the structure upfront, how then do you still get them to work within this framework?
I think, yeah, that's like one thing where you will start understanding it when you do one of your use cases. I think the one thing I have seen is like means build a self-service like data layer where people can start looking at it, that data set to solve the problem, like instead of like worrying about like how do you bring the data there. So our self-service model was like bringing the lowest granularity of the data into data lake so that when you want to look at it, so you can start building up your data mart or like next future layers. Means it's not like business will be not doing that part of right now. So they'll be worrying about like, so I want like this transactions, set of type of transactions, I want to be aggregated at a certain level by month, by years, or something like this by a record keeper or advisor. If I want to do something like this, so these are like you get the lowest granularity data into this lake and start answering that question by a data analyst. Once you have those data sets, you think that data analyst has done a good job of solving all the use cases, whatever you need, and you have a quality check done. You can publish that as a data set to somebody to start using, thinking like, oh,
Oh,
this is very much at a high aggregated level, instead of saying that everything is at starts from scratch.
oh, I see. Oh, wow. Yeah, that
So
changes.
yeah. So I think instead of like saying that data lake is like ready for everything, I'll say you might not know half of those stuff. So you might be worried about like, okay, that same domain team might know things a lot better than your team or some other teams. So they can actually look at the data set, analyze it, and build that thing. When you say this ready data set is ready to consume, right? Then that's where you say, okay, now my data governance comes in. Tell me, how do you calculate this field? So if we say, so I am part of a asset under, I mean, a finance company where we worry about a lot of assets under management. So our way of calculating assets under management is likely different than how actual business teams think, right? So if we start thinking like, instead of we calculate, we'll say, ask them, okay, when you say assets under management, they do a lot of calculation themselves. So we ask those questions to them and we build that assets under management value from their calculations, and we document the same way so that they understand and they use it the way they expect,
Oh,
instead of we coming up with something for product manager or something for different teams. So we actually standardize that assets under management value from our team based on their calculation, and we publish that value saying that this participant and this is his assets under management and this is how we charge him on it.
oh, see. Wow. I see why you said it's always on that. It's you keep working on it. It's not like a destination, it's a journey.
Yeah.
So Xiao has a question, and I'll read the question the way they've written it. How do we decide what constitutes a domain in our organization? Is it by business function, application, or product line? Which domains will provide the fastest AI ML value?
Okay. I think it's very depends on your organization. I'll say if it is a domain, if you have a different departments, so that becomes your domain. Or if you have a very big, say, let's say, I mean, say in Morningstar, we have wealth, we have separate retirement, we have separate uh, advice management. They have like a lot of other departments. So we make our organization itself is a domain, because we know, think about like what your team can solve it, or where your team can produce the data and say we know things better than anybody else about this data set. So that can become a domain at one point, or your subdomains can make up into a main domain. So think about like, say, if finance, but you have like a finance under operation finance might be one thing. There might be another finance which works on billing. There might be another finance which works on means even the operation income might be worried about like making small salaries or anything like employees. That might be like one piece of it. So it's like subdomains can make up to your main domain. So you need to worry about like how you structure your data sets.
Mm,
So I'll never say application become a product, means application or product can become a domain. I will never think about it like that. So I always think a business can define what can be a domain mostly.
So she always come from the business side of things, not from the application or tech stack.
Yeah, application will be a solving a problem within a business. So I always think application is like one problem solver. It's not actual the entire business. So if you have one application which will they define the entire business, then it can become its product or it can become its domain. But I'm saying like it is like one piece of it.
Yeah, good. And we come to the last question, at least that is here. So Rajesh, I'll read the question as I have as I see it here. In a data mesh architecture, how do we establish, govern, and enforce cross-domain semantic consistency for core business metrics without reintroducing centralized bottlenecks and also managing the ownership?
Cool. I think we are like speaking about where data producers and consumers, they need to speak the same language from every domain. If I want to define it, how do you define it? That's where our like started conversation. Like if I want to be a consumer, what do all I expect from a data producer? Okay, so those are our rules when we started with that, and then we started improving it, saying that okay, if I want a product manager being a data consumer, how does they defines a data set? How do they expect it? So what is the quality they expect? And if I want a data owner to be worried about like the entire data set, so what are the different issues in production which can impact the data set? So you need to tie those pieces up as well. So those are like some rules where we said, okay, you will build a data lake, but we'll be like worried about infrastructure for it. So what we did was we made our infrastructure when we onboard it, right? We need all these pieces to be like answered when we say our configuration file, when we onboard a data set, it's like an application where we defined our rules with configuration. So when you answer those configurations, those are like rules for your data set to be onboarded onto that platform. So you don't need to worry much. So you just need to produce your data set, answer this. So it inspects the data set and it asks a bunch of questions on it, saying what is it this column means, what does the data
Mm.
set means, who will be the owner, who will be the access, and what types of access you need, and do you have data domains, data access layers defined already? If you already have it by your data group, or is anything different from your security or anything? So if you want to like say you have a secured vault for some of these PAA data. So those are like some things part of our framework, which we already defined, and my team gives it to everybody because we are the infrastructure owners for this.
Mm.
So that's how we controlled the actual ingestion and everything into the governance layer. So that's where our we worry about only the governance part of it. Who will be approving it will be their product managers and their domain owners. If they do a bad job, if they approve it, it's like problem they'll be like resolving it in future.
It's a very great way to kind of put it. So, and that's the we. I know we've gone 10 minutes at both time. Do you have 5 more minutes? There are two questions we ask every speaker we get. So, but we also want to be respectful of your other plans. Is it okay if we ask you? Do you have 5 more minutes for?
Yeah, sure. Go on.
Okay, all right. So we have two more questions that we ask every speaker we bring. Question one is your journey, how you got into this space and, you know, got this far and, got so deep in it this way. Has it always been that way, even from when you were maybe in high school, you always knew you were going to do, engineering, data engineering and work, in a particular type of company, and it has always been clear, and you just went in a very systematic way to achieving where you are now, or were there twists and turns? What can we learn from your journey? So that's question one, to telling us about your journey to how you became this domain expert you are now. Then
Uh,
question, okay,
Go on. Yep.
okay,
Second
I
one.
just want so that you can answer them
Yeah.
together. So the question two is your advice to people who if they are just starting their own journey, I know things have changed a bit in terms of tools and distractions, and it's very difficult to be focused these days. What will you give as a clear way to navigate becoming a data master like you now?
Cool. I'll take the first one. So the first one was like about data journey. So I started like everybody else. Like I was just joined as a programmer to start with. I started with .NET and Java both because I was very hands-on on any programming. I can pick up any programming language very easily. So I started with Java. I started working with Sun Solaris when I started. So I worked for Sun Solaris for a few years and then moved on to few other companies and started thinking, oh, Java is great. And then on the way, it was like, oh, it was like too much. So I started like seeing like a lot of .NET. So I started that as well at one point because it was very natural. When you know one language, you can pick it up other language. And the .NET and Java was very much same because it's all both are like object oriented, so they are like speaks about same type of structure, language, everything. So it was very easy when I moved out and like started doing .NET. And then after a few years, I luckily, I think I will not say it's like I chose, but luckily I got into one project where I was working for Fannie Mae. So where we got data from different mortgage companies, and we want to like convert that application of data into the format where Fannie Mae accepts their application. So we
Mm.
started working on a application called electronic data interchange, which is like a EDA application that time, which was done by a BizTalk. It was a weird tool that time. It was like a Microsoft BizTalk. It's like one of those EDA tools. I started with it. I got into means very much. I liked it because it's like a XML format. You read something and you can convert into another format and start using it. That's where my EDA journey started, and then I found it very interesting. And then I moved it into warehousing, data warehousing, because that's where I started seeing like I might start liking the data than programming. So I moved into data engineering, means data warehousing, the regular data engineering stuff. And then as progression helped me move into big data solutions and learned my lessons when I moved from big data to cloud. How does that cloud works, and what is the problems with the existing big data solutions? And then I expanded what I learned from regular big data to cloud big data. And then I continued. I think even machine learning and everything as a I experiment a lot. So
Yeah.
this is like part of journey where I experiment every 2 years to 3 years. I learn something new and then I started implementing part of my journey.
Wow. Wow. I don't think anybody can replicate that your approach. Now that's you started from the deep end. It was almost like, you went to the bot you started from the bottom of the ocean, technical difficulty wise. Java and .NET is considered way more, you know, less forgiving. One cannot just feel their way through. So it's interesting to hear your journey, and that's, you are able to apply all of those, your approach to learning things new to progress to where you are. So what would you give as an advice, as like, if there's somebody who is like where you are, I don't know, 30 years ago, where you are when you started with Sun Microsystems, and that person is talking to you and is saying, I want to move into this field. What will you say is the approach they should take?
I I apply this business outcome approach for everything in my life right now. So whatever I want to say, what is the end looks like, let's start back from there. So if I want to be a programmer, or if I want to be a data engineer at certain pieces, I'll be looking at what is the job looks like, what is the job role expected. So I'll go back from there. So these are like job roles or job responsibilities looks like. These are the tech stacks looks like. So I'll go backwards from there. I usually do it for every 3 years once. So if I was like a couple of years back, I was learning machine learning very religiously. I want like I'm not great at statistics. If I want to like learn something for machine learning, I want to be good at statistics. I did my MBA with my statistics and machine learning. and I wanted like go from there. So I did my backward saying that okay, what are the roles in machine learning world and what are they need and how do they means what are the responsibilities they look at it. And then I started saying okay, these are my role. So I want to like go from here to there. So what is my things I want to experiment before I say I learned it. And these are like projects I want to do it next 3 months. I drop my roadmap for that and then start achieving small pieces. I'll not be saying that I'll be
Wow.
doing it in 2 years, but I'll be like doing like every
No.
month end checkpoint saying that I'm done with this class. I'm done with this subject. I know this end to end.
Wow. Wow. So you've engineered everything. Like it's an engineering approach.
Yeah,
Uh,
means you need to be that because means when I have means I have a team in Mumbai means I have a team in Mumbai, Chicago, and one in Toronto. So when I speak to them, I always doesn't speak to them how do you solve the problem. I speak to them how do you what needs to be solved, and I want them to be like making a decision out of it because I don't want to like spoon feed the solutions or else they'll never know the solutions by themselves. So my team experiments a lot, fails a lot, it doesn't matter. They'll be like coming out with good solutions next time. So
yeah.
that's how my team grows and learns. So we are the team who has implemented LLM solutions or anything. When we were everybody was implementing, we were like failing badly because our approach was to say try out everything whatever we can do and implement and scale it. So our problem is to scale. It's not implementing a solution and failing it in next 6 months. We want to implement it and scale it. We want to do it both in one time. So we implemented a solution like we actually brought in harness engineering which we want to do. So that's like something it started with very small and now we actually built out a web application which is not our mainstream focus, part of data engineering team. So now we are actually trying to push that into production.
It's a good approach to take that you've shared. Thank you very, very much. So, we have come to the end actually, and I don't see any other questions. And I think some people are even had to go because this time of the night, people have things planned. But like I said, people always know we record the session, so they would always go watch the parts they missed. But thank you very, very much. It's a pleasure hosting you. I've learned a lot personally, which I'm not surprised, but I know everybody has also learned a lot from what you've shared. And for me, this gives me a much bigger picture of what the ideal, what if everything is working properly, what it should be like, for a large organization that has different domains. I wanted to say departments now, but I'm going to use the word domains more. And this is very eye-opening. It helps me to even understand why some things are in place at some of the organizations that I come across. And thank you very, very much for being very open, sharing your knowledge and helping us to see the practicality of some of these technical things. And have a good evening ahead. Thank you very, very much. And with that, I will bring this session to a close.
Thank you, Michael. Thank you, everyone, for this listening to this. My rant for an hour. I think you will enjoy it. And if you have any questions, please reach out to me on LinkedIn. I'm very active
Oh,
on LinkedIn and for means anything if you want like learning or anything on data engineering or machine learning.
yeah, I've even shared your WordPress too and your LinkedIn.
Oh yeah, sure. Thank you.
Yes, sir. Thank you very much. Bye to everyone. Thank you for staying till the end. So I'm ending the meeting now.
Yep. Thank
And
you. Have a good one.